So in this video, we're going to take a look at an alternative method of finding the HCF and the LCM of any two numbers. So let's just take a quick look at some of the examples we've already seen in the previous videos. So I know already, for example, that I could write 16 as 2 to the power of 4. I know as well as that, I could also write 20 as 2 squared times 5. And if you want to know how to do that, please look at the previous video on writing numbers as a product of their primes. Now, from here, I actually can find the LCM and the HCF. So let's start off with the HCF of these two numbers, 16 and 20. So what we're going to do is just look at the two writings of their in terms of their primes and compare them and see what's the same. Now, to help us do that, perhaps it's easier just to write this in regular form without the exponents. Now, you can see clearly here that both of these two contain 2 times 2. Those are the only things that are common to both. And so this is going to be the highest common factor. The highest common factor of 16 and 20 is 4. So that is quite simple. The LCM is a little more challenging, but it's still very understandable and very doable, right? The LCM of 16 and 20. Well, what we're going to do here is we're going to write out one of these. Now, it doesn't matter if we start with the 16 or the 20, but let's just choose the 16 to start with. So this LCM will be 16, so 2 times 2 times 2 times 2, and I'll put them in brackets to emphasize the point. Now, we look now down at the 20, which was 2 times 2 times 5, and see if there's anything there that we haven't already used. Now, we've already used 2 2s at least. In fact, we've used 4, but we've definitely used 2 2s. So we haven't yet used this 5. So what we're going to do is times that by 5. And this will give us our answer. So 2 times 2 times 2 times 2 is 16, as we know, times 5, well, the LCM is going to be 80. So that's our method for finding the LCM. We can find that and the HCF by looking at the numbers as a product of their primes. So let's try a more complicated example to make sure you've really understood this. So in this case, we're going to choose to find the LCM and HCF of 60 and 102. Okay, now before we even get started, we need to write these as a product of their primes. Now, you can use a factor tree to do this, but let's just say we've got that sorted and understood, and I'm going to help with this bit. So 60 can be written as 2 squared times 3 times 5. 102 can be written as 2 times 3 times 17. Okay, now we've got this understood, let's see if we can find these two things. We'll start with the HCF because it's easiest. So I can see there is at least 1 2 in both of those lists, and there is also a 3 in both of those lists. So the HCF is going to be 2 times 3, which is 6. The LCM is a little different. Let's start by writing out one of those. So we'll start off, I'll put it in blue to really emphasize this point, 2 squared times 3 times 5. All of those numbers there are definitely going to be coming together to make this LCM. Now, let's look at the green, the 102. Well, I've already used a 2 and a 3, but I haven't yet used a 17. So I'm going to need to use that 17 as well. So if I multiply 2 squared times 3 times 5, which we already know is 60, by 17, I'm going to have my LCM. That's going to be 1020. Okay, I hope this gives you some insight into how to find the HCF and LCM in a different method.